All right, hello everyone and welcome. If you're studying for your FSc A levels, or especially if you're gearing up for the ECAT, you know resistors are everywhere. And look, by the end of this explainer, I'm going to make you a promise. You will be able to look at any resistor problem they throw at you and know exactly what to do. All right, let's get right into it. So, here's the game plan for our journey today. We're going to start with the basics, what a resistor even is. Then we'll learn to read those color codes, nail down Ohm's law, and then tackle all the different circuit types. After that, we'll get into power and finish up with some killer tips to make sure you crush your exams. So, first up, what is a resistor? It seems like a simple question, right? But, if you really get the why behind this component, all the math that comes later, it just clicks. It makes so much more sense. Okay, so there's the official textbook definition. Passive just means it doesn't create energy. It can't add power to a circuit. Its whole purpose in life, its one and only job, is to resist or limit the flow of electric current. That's it. But how does it actually do that? Well, this is the cool part. It's all about physics on a tiny scale. You've got these free electrons trying to zoom through the material, but inside, they're constantly crashing into atoms. Every collision slows them down and turns a bit of their energy into heat. So resistance is basically just a microscopic traffic jam that gets warm. And just like you wouldn't use a hammer to turn a screw, we have different resistors for different jobs. Think of carbon film resistors as your all-rounders, your general-purpose go-tos. When you need things to be super precise and quiet, you use metal film. And for heavy-duty, high-power stuff, you bring out these big, bulky wire-wound resistors. All right, let's get practical. You need to be able to look at a resistor and know its value. It's time to decode those colorful stripes. This is like learning a secret code. And trust me, it's way easier than it looks. And the key to cracking this code? It's this classic phrase you've probably heard a million times. B.B. Roy, Great Britain, very good wife. This is your secret weapon. Seriously, burn this into your brain. It's a lifesaver when you're in an exam and need the values fast. So each word in that B.B. Roy phrase lines up perfectly with a number, starting with black at 0 and going all the way up to white at 9. And check out that multiplier column. It's just a fancy way of saying add some zeros to your number. The ones you'll see most often, for sure, are black, brown, and red, so really make sure you know those. Okay, let's do a real one. Let's say we've got a resistor with these stripes: brown, black, red, and then gold. Band 1, brown, is a 1. Band 2, black, is a 0. Put those together, you've got the number 10. The third band, red, is our multiplier, which means times 100. So 10 times 100 is 1,000 ohms, or 1 kiloohm. And that last gold band, that just tells us its value is accurate to within plus or minus 5%. See? Easy as that. All right, now we're getting to the absolute heart of everything we're talking about today. Section 3, Ohm's law. This is the big one, the golden rule of electronics, the single most important formula you need to know. So, the law is super simple. Voltage equals current times resistance. V equals I times R. That's it. It perfectly describes how these three things relate to each other. The magic here is that if you have any two of these, you can always figure out the third one. It's like a little puzzle. Let's work through a problem you totally see on your ECAT. You've got 3.3 volts across a resistor and 15 milliamps of current flowing through it. What's the resistance? First, we rearrange our formula. R equals V divided by I. Now, and this is the number one spot where people make mistakes, you have to convert your units. 15 milliamps becomes 0.015 amps. Then you just plug in the numbers, 3.3 divided by 0.015, and boom, you get 220 ohms. Okay, great. So we've handled single resistors. Now, what happens when they team up in a circuit? This is where things get interesting. And honestly, this is where most of your exam marks are going to come from. You're going to want to screenshot this slide. This is your Bible for circuits. For resistors in series, when they're lined up end-to-end, the one thing you need to remember is that the current stays the same through every single one. For resistors in parallel, where they're side-by-side, the absolute key is that the voltage is the same across everyone. They're total opposites, and knowing that is half the battle. Okay, so series circuits, they're the easy ones, for real. To get the total resistance, you literally just add them all up. So here, 100 plus 220 plus 470 gives us 790 ohms, easy. Then you just use Ohm's law on the whole circuit. 9 volts divided by our total of 790 ohms gives us 11.39 milliamps. Now, parallel circuits. The math gets a little more interesting. But for two resistors, there's a fantastic shortcut. Just multiply them on top and add them on the bottom. So that's 100 times 200 divided by 100 plus 200, which gives us 66.67 ohms. And here's a pro tip, a little sanity check. Notice our total of 66.67 is smaller than our smallest resistor, which was 100. For parallel circuits, that will always be true. And now, for the main event, mixed circuits, which are just a combo of series and parallel. The golden rule here is simple. Always, always tackle the parallel bits first. Turn them into one single equivalent resistor. Here, our 200 and 300 ohm resistors in parallel become 120 ohm resistor. Now our circuit is just a simple series circuit, 100 ohms plus our new 120 ohms. Total resistance, 220 ohms. All right, we're on the home stretch. So knowing the resistance value is one thing, but what about the real-world stuff, like managing heat and controlling voltage? Let's dive into that. So power is basically a measure of how much heat a resistor is giving off, and it's measured in watts. You've got 3 ways to calculate it, but listen up. The one they love to test on, the one you've got to know for the ECAT, is P equals I squared R. Remember that one. And this right here shows you why that formula is so important in the real world. Let's find the power for a 470 ohm resistor with 25.5 milliamps going through it. We use P equals I squared R, remembering to convert to amps, and we get 0.306 watts. Now, a standard resistor is rated for a quarter watt, or 0.25. Our value is higher than that, so we've got to grab the next size up, a half-watt resistor. Otherwise, you're going to smell smoke. Okay, another super practical circuit you'll see everywhere is the voltage divider. It looks simple, just 2 resistors in a line, but it's a clever way to get a specific, smaller voltage from a bigger one. The formula tells you exactly what you'll get. This is a fundamental concept used in all kinds of electronics. And that brings us to our final section. Let's talk strategy. How do you take all this knowledge we've covered and turn it into top marks on your exam? Okay, rapid fire tips. These are the game changers. Always write down your formula before you plug in numbers. Show your units every step of the way. For mixed circuits, redraw the circuit as you simplify it. Always do that quick mental check for parallel circuits. And I'll leave you with a fantastic ECAT trick. If you have a bunch of identical resistors in parallel, the total is just the value of one of them divided by how many you have. It's a massive time saver. So before we wrap up, I want you to ask yourself this question. Which of these gives you the most trouble? Series, parallel, or those mixed circuits? Be honest with yourself, because figuring out where you struggle, that's the first step to actually mastering it. Focus your practice there, and you're going to do great. Good luck with your studies.